All right, we're back doing the second portion of the simple harmonic motion experiment, and this is part C, period of oscillation. And we're going to use the same FET simulator from University of Colorado, but this time instead of stretching it, we're going to oscillate. We're going to let the spring oscillate with the mass on it. So we're going to set the spring strength, the K constant, back to what it was when we put it. We're going at the trials, the total suspended mass, the trials, they give us 5 trials. So we're going to do 100, 150, 200, 250, and 300. So we're going to start at 100 grams. So we're going to put that 100 grams on here, and it's oscillating, as you can see. We're not going to use a ruler. We don't necessarily need the well, we can use the unstretched line. We can use it as a starting point when we use our timer, our stopwatch. So now, where do we start the stopwatch? Well, I find it easiest if we start it right when it crosses that line. Now, as soon as it crosses that line, that's zero. It doesn't complete the cycle until it comes back up to the top. So when I start at that 0, you won't hear me count 1 until it makes a complete cycle. And we're going to count 10 and come up with a value. So as soon as it goes up, I'm going to start it. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I got 9.02 seconds, 9.02 seconds. Okay, that's a little longer than what I have. I've already have it populated, but I'm just showing you how I went about doing the experiment. Now, I did it 3 times and got the average of the 3. Well, let's just do it again. As soon as it crosses, that's going to be 0. 1, oops, I reset it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 8.84. That's a little more in keeping with what I got the last time. So I've got the data. You'll see it. I'll post it. But I just want to show you how we went about doing it. Let's reset this 0 to 0. Now let's go 150 grams. Oh, what happened? It slowed down, which we expect it to. All right. As soon as it hits the top, I'm going to start it. But that's a 0 count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10.91. And that's close. Again, that's a little bit over, but I've already populated the table with the data. Now let's go to 200 grams. And what do you see happening? It's slowing down even further. So reset the clock, and as soon as it hits the top, I'll start it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 12.61. That's close. It's a little high, but not. I was getting 12.44, 12.56. You'll see the data. Let's add another 50 grams. So it's 250 grams, 0.25 kilograms. Much slower, much slower. Let's reset the clock, and as soon as it hits the top of its cycle, we'll start it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 13.89. Yes, I was getting about 14. One of them I got 13.94. So that's in keeping with our with my initial test. Okay, let's max this out at 300 grams. Let's reset the clock, and this is our slowest one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 15.39. Very close to what I got in the past. So let's stop this. Stop the oscillation, and let's switch screens. Let's go to the iPad, and here's the table all populated, already populated from when I did the experiment the first time. And you can see that I have the masses here. Those are the masses. These are the times, the 3 on in each rectangle there. These are in seconds. The times, I took 3 trials of each mass. I took a number of oscillations. I took 10. I didn't know what they want in that parentheses there. I just left it a dash, and I came up with the average of those 3 values. And so here's our average periods here, and then we need to square them, and that's where we get this this data here. It's the t squared. Now if you recall from let's see. Well, this is the equation. This TI 16.3. The period is equal to 2 pi times the square root of the mass times the K constant. So in order to find the K constant, we have to solve. Let me erase that. K is equal to T 2 times pi squared, the quantity squared, divided by the slope. So we're going to get the slope. So we plot T squared on one and the mass on the other, and you're going to let's use red. You're going to draw your best fit line through those data points. That's close. And then you take, let's change colors. You take 2 data points here, and you get the slope just like we did previously. And then you're going to solve K is equal to 2 pi squared over the slope. All right, and that's what you're going to how you're going to compute the K. Now the percent difference of the K's in B and C. So you're going to get a K here that you calculated, and you're going to get a K here, and so you want to do the percent difference is we'll call it K part B plus no, I'm sorry, minus K over C divided by KB plus KC over 2, the average. And you multiply that by 100, and you'll get your percent difference, okay? The percent difference of the Ks. So go ahead and I've given you the data. I'll post this on Canvas, and we'll stop the lecture at this point.